webinar of our new UIA season, back from summer holidays and vacations, even if most of us were stuck in our homes. We are really excited this week to have a series of scientific related webinars. Today we'll be dealing with the issue of unmanned vessels, but later this week we'll also be dealing with telemedicine, genetics, climate change, and then on Saturday we'll be having a summary YouTube session, something new we haven't done before, where we'll be getting feedback and engaging our audience with respect to scientific issues. So I'm really excited about this. It's a new initiative, and it's one of many new initiatives we have going on in this new season at UIA, along with Women Bar Leader Day and a number of other events leading up to our virtual Congress on October 28th, 29th, and 30th. So with that, I'm going to introduce Alberto Pazzino. You'll see that today many of our panelists are from Italy. We were supposed to be in Italy, in Trieste, in the spring, but of course with COVID, we changed that into this virtual Congress. Nevertheless, we have a wonderful set of panelists from Italy, as well as one panelist from fellow Californian here in Silicon Valley. So we are very global this morning. With that, let me turn it over to Alberto Pazzino, the head of our transport law, who will introduce our moderator and our panelists. And I wish you all a wonderful seminar this morning. It's great to be back in the saddle as we start this September and this new UIA season. Thank you very much.
So thank you very much, Jerry. My warmest greetings to all participants to this webinar. I have been requested to introduce in a few minutes the concept of the Science and Law UIA event, which has been co-organized by a group of 4 lawyers, of which I have the privilege of being a member. 2 years ago, when Trieste was awarded the opportunity to organize the 2020 European Science Open Forum, we immediately seized the opportunity of having a large number of brilliant scientists gather in Trieste with an amazing group of lawyers from all over the world to discuss and debate key areas of common interest. The starting idea was that scientific progress runs the risk of being hampered by laws conceived in less scientifically advanced times. The world is changing at an incredibly fast pace, and the legal community is struggling to evolve at the same speed. Emerging technologies and scientific discoveries are raising novel legal issues and rapidly transforming both the substance and practice of law in almost every area. Unmanned vehicles are a very clear example of it. It is probably accurate to state that their full advent does not depend on technological issues that science cannot solve, but rather on legislative policy decisions. The main one being how to properly channel liability and allocate it among the ship owner, the vessel herself, or those who developed her. Similar examples might be drawn also with concern to the 3 areas which we will explore in the forthcoming days. The way to implement such idea has been to invite 1 or more scientists to give a presentation identifying the issues in their field of research that are in greater need of solutions offered by the law, and then 2 legal experts specialized in the same subject, trying to provide answers to the issues posed by the scientists. We worked for months to set up a physical congress, which we did, and then COVID reshuffled the cards and imposed us to adapt the original physical version to the virtual one. However, the substance did not change, and we have organized 4 amazing panels, which will give the audience juicy chunks of food for thought. Today, you will attend the first one, while the 3 others, focusing on telemedicine, genetics, and environment and climate, will occur tomorrow and on September 4th. Saturday afternoon, we'll have the last event. At 4 p.m., during a hybrid event broadcasted on YouTube, 5 experts will report the results of the 4 webinars and give their view on how science and law speak, if I may say so, to each other. If you haven't registered yet, visit the UIA site and do register. So welcome again and enjoy the discussion. Now, Paolo, the floor is yours.
Thank you. Good afternoon. My name is Paolo Scialla. I'm Principal Specialist for Lloyd's Register, working in the Technical Support Office here in Trieste. First of all, I would like to thank the International Association of Lawyers and the organizing committee of this event. A particular thank you to Mr. Alberto Pasino, who invited me to facilitate this event, and to Colette Soren from UIA, who gave an excellent support for the realization of this webinar. It's a pleasure for me to introduce 4 speakers who have a huge experience in technological, legal, and ethical subjects, and who will help us to enter the discussion of how the latest development of the industrial automation is moving to the autonomous navigation on the seas. The concept of unmanned vessels is stimulating interest, not only for the benefits and the risks that could bring to the transportation sector, but also for the legal and ethical implications that we can easily imagine such kind of technology will introduce. A quick advice to the audience, the webinar is using a platform that have a Q&A section on the bottom of the display, where you can type your question to the speakers. Then I would kindly ask you to use that section, and I will collect your questions and ask to the speakers at the end of their presentations. We will start with Engineer Claudio Longo Bifano, who will introduce the subject from a technical perspective. Mr. Longo Bifano is the Senior Business Developer for Sistema SPA, that is an Italian company owned by Fincantieri Group. Mr. Longo Bifano has more than 20 years of experience in the proposition and realization of innovative solutions for critical and demanding assets that operate in complex environments. His recent working activity is based on the definition and implementation of a new generation of unmanned surface vehicles, and he has worked in Europe and Middle East with multinational companies in naval, aerospace, and IT sectors. I hope we all enjoy this event, and I would leave the stage to Mr. Claudio Longo Bifano for his presentation. Thank you, Claudio.
Thank you very much, Paolo, for the introduction. And good morning, evening, all. And it's a real great pleasure to have the opportunity to participate to this Science and Law Forum. And I want to give a special thanks to the organizing and all the participants that join us from all the continents of the world. I saw people from Europe, Australia, Africa, Asia, America. It's impressive. So let's start with my presentation that want to provide elements and ideas starting from a more technical point of view. So my idea is to provide you a general overview with a lot of elements that we can discuss later. So Sistema is the company where I'm working, and it's a Fincantieri company that provides automation, navigation, communication, command and control solution for ships. And Sistema is working to develop innovative and challenging unmanned vessel project today. Just a moment. Okay. So in the near future, unmanned and autonomous vessels will update and enhance performances of marine and maritime operations, becoming more consistent, reliable, and safer for all the actors involved. Clearly, the current trends today show the increased use of unmanned vessels, especially in aerial, in air, or in ground, and unmanned surface vessels are following this trend. So, due to the fact that more autonomy is provided and less human interaction and interference is required, the analysis of the different level of autonomy is essential to define responsibilities boundaries, and we will be analyzed later during the next slides. We will use the term MASS and NASS to identify the maritime and naval autonomous surface system, where maritime clearly is linked to civil application and naval for military application. So the MASS-NASS can be considered ships under the control and responsibility of a commander that can be on board, like usual, or off board. Relating NASS, where we speak about military, the responsibility is usually of the flag states of the ship. So autonomous vessel will give the chance to perform mission not previously feasible due to the risk or lack of availability of human operators. So speaking about the global trends impact on transportation autonomy. So there is 5 challenges that have impact on unmanned solution. So there is the world of digitization that grow every day more and more, like Internet of Things, big data, artificial intelligence, Industry 4.0, cloud, edge computing, cyber, or all the collaborative technologies that are growing more and more. You can imagine to swarm or group of drones that collaborate together. After that, we can speak about the global connectivity, so that it became day by day more and more pervasive and became safer and stable and everywhere. So growing population congestion require additional services that can be delivered with unmanned solution. And also climate concern and sustainability is a big issue that we will analyze later. On all of this, there is clearly the ethical impact, the legal implication to use this kind of solution and platform. We can see today that there are a lot of unmanned systems on ground and air. So we have solutions that use helicopter, aircraft, or drones, or we start to speak about automatically car, or buses, or driverless subway, or so. Usually the maritime market follow this evolution because it's an old market and take time to transform. But in the future, there will be a lot of advantages. So there are, I select 5 different advantages. That is capital expenditure savings, that means lower construction cost and increased vessel efficiency and reduction in crew spaces. OPEX savings, so operational expenditure is mean crew staff reduction, that means less salary, insurance, supplies, and also, why not, fuel saving. From safety point of view, we have the potential to reduce human-based error. You consider that now the human errors contribute about 80% of marine casualties and problems. Enhanced revenues, that mean increased transportation capability due to the flexibility in space design, allowing more profit. And at the end, sustainability gain, that means fuel saving due to lighter, more efficient, productive, and aerodynamic ships and efficient use of space. So you see that there is a lot of advantages in the future that will bring this market to go ahead for unmanned solutions. So what I want to discuss now, I'm waiting the change of the page, okay. It's about the trends and enables. On the left part of this slide, we can see the automation trend that start with automated systems that are used today normally, where the sensing and monitoring of the platform is involved, and evolve a smart and remote solution where we optimize the platform behaviors to arrive to semi-autonomous. In this case, we insert software integrity and cybersecurity with the goal to have autonomous, full autonomous system that have embedded artificial intelligence and capability of decision. So on the right part, it's interesting to highlight the key enablers for unmanned vessels, according to US Navy vision, that are endurance, autonomy and precision navigation, command, control and communication, advanced payload and sensor, and platform integration. That's mean increased capability to launch and recover this kind of vessel through host platform. Okay, I want to introduce now an important concept, that is the concept of autonomy levels, according to main difference classification. On the left side, we have the IMO MSC 100 classification that put the man in the center. There are 4 levels where in the first 2 levels, 1 and 2, the seafarers or crew are on board, while in the 3rd level, the ship or the seafarers is removed. In the 4th level, the vessel is totally autonomous. Existing unmanned vessels today are positioned between level 2 and 3. And it's important to highlight, looking to the red box on the left, that we have a clear manned responsibility till level 3. So if we enter in level 4, the ship is totally autonomous and it's not possible to have a clear responsibility of a human. On the right, there is the so-named Sheridan classification that put the computer in the center. There are 10 different levels of autonomy, and the computer takes control going through level by level and starting from level 1 of more functionalities and decision, arriving to have the complete control and ignoring humans. In this case, we can identify a clear human responsibility till level 5. Starting from level 6, the machine take control and give less capability to control for humans. So I introduced this. Okay, I introduced this to summarize this concept, identifying 4 different typology of ship. So we have manned ships that are the normal ship with onboard seafarers or crew. Remote, where we have the control of the operation that is done by ashore. And we have semi-autonomous, where the ship has a autopilot advanced capability to take some decision about the route or what he has to do. The final task, the final goal is the autonomous, where the vessel is completely autonomous and a shore operator can intervene at its discretion. Okay. We can highlight that the state of the art of the actual program is at the level of semi-autonomous ship with dual use capability. To arrive to full autonomy, we need to have a full artificial intelligence capability and a legal framework that set a wide frame of rules for different applications and missions. The construction and operation of full autonomous units is expected to happen, from my point of view, not before than 10, 15 years from now. Well, as I said, it's important to have a dual-use approach to reach a commonality of the solutions offered in civil and military application. And this is the path that the main projects are following today. The list of enabling technology for MASS and NASS solution have a main factor that is the role of artificial intelligence. That includes clearly machine learning, deep learning, expert system, and are ordered in this slide according to the growing TRL. The TRL is technological readiness level. So that means that the technology in the lower part are the less mature nowadays, while the higher part report the more mature that can be done today. So that means that at the end of this slide, like situational awareness and collision detection system is very advanced and will arrive with new developments. Today is just starting to have solution like this. Some ongoing projects for military, NASS, or MASS civil are reported in this slide. All the solutions presented are to a smart or semi-autonomous level. In the military segment, we have some solutions like Protector and Vigilant that are operative vessels that have reduced dimension. We are speaking maximum 70 meters, and are used for surveillance, reconnaissance, and protection mission. While the last one on the left, that is the Sea Hunter, is a US project that shows how dimensions, endurance, and capability will grow in the next future. Americans have many programs that involve the future use of medium and large unmanned surface system to expand the Navy's capability for the future. On the other side, in the civil segment, we have some example of solution for automatic transport, for container, for goods, people, or for harbor services. There are so many founded programs all around the world to demonstrate unmanned vessel capabilities for this kind of mission. Okay, all this fast introduction is to show from an architectural point of view our split of a MASS or NASS solution. So usually we are engineers and we work splitting things in building blocks, and we can check in this picture the platform that is composed by hull and structure and all the platform system. This is standard system of a normal ship, and the unmanned package. So the unmanned package is built by guidance, navigation, and control system, by the remote control station that permit to stay in contact and operate remotely the ship, and from the communications of the ship with the ground, with ashore. Now the communication clearly can be satellite, HF, VHF, whatever, 4G, and so on, and are very important to have and continue to have the control of the ship. On the box named Situational Awareness, we intend all the capability of the system to have a wide integrated picture of the situation and the scenario around the ship in order to take the right decision. The last package is the mission system. That is the mission package. That is the payload that is, let me say, specialized payload for different missions and change case by case according to the needs of the customer or the mission. I want to show you some points that are a red triangle. That means that are critical issues that can impact the different blocks and create problems and questions. So some example can be, I don't know, the ship lost the connection and have to decide autonomously how to proceed, for example. Or I have a cyber attack to my platform that can take control of the ship, forcing some unwanted actions. Or the system fails to analyze the scenario and take wrong decision. So clearly, we are speaking of a very high level machine that can take decision, but clearly more the complexity grows and more the problem can be. In this table, I show some critical mission for a military system. We are working on a military application too, and we see that there are different kinds of missions, like mine countermeasures, anti-submarine warfare, environmental analysis, patrolling, intelligence, surveillance, and reconnaissance, maritime security, support, or surface warfare. So, but it's interesting in this slide to see that in the future, military unmanned system will probably be armed. They will have guns or missiles or torpedoes, and the loss of control or automatic decision of a ship can become really a big issue. So I want to know now to summarize the elements discussed, and I created a table that present the advantages or disadvantages using MASS and NASS solutions. So the MASS NASS solution will reduce the risk for humans, especially for critical mission, reducing the cost with higher mission versatility, simplicity, endurance, and will become a strong deterrence. But on the other side, the MASS NASS are machines and are exposed to many problems, can lose connection, take wrong decision, or be attacked, or create unwanted damages, and can be perceived like unfair, violating wars or warriors' rules, and however, lowering the threshold to start a potential action or conflict. So who own this can do action without risking humans. And this is a real risk to take under, to don't consider very well an action. Well, in the last slide, that is in the appendix 1, I just, for your reference, I put a list of main international laws and applicable rules for this field, for MASS and NASS. This is the rules we are studying to develop something that is aligned with this, but clearly the list can be bigger. So thank you for your patience in this more technical issue. And I pass the word to Paolo. Thank you.
Thank you, Claudio. Thank you very much for your very interesting presentation that is introducing the subject from, at least from a technical point of view, that is the base of our further discussion. Now, our schedule expects that Dr. John Murray, General Manager at Calidris Partners in Silicon Valley in California, US, will have the stage. Dr. Murray is an early stage technology investor and startup business consultant. He has advanced engineering degrees from Stanford Dublin Institute of Technology and the University of Michigan. He is a member of the Technical Policy Council for the ACM, Association of Computing Machinery, which advises US legislators and government regulators on technical policy matters. Dr. Murray held technical leadership and executive management positions at several large international corporations and innovative startup enterprises, and recently retired from the Computer Science Laboratory at SRI International. So John, the stage is yours. Thank you.
Great, thank you everybody, and it's an honor to be participating here today. I'm quite fascinated with the level of detail that the previous presenter went into on the complexity of this space. As I think about the way that systems are deployed in a variety of different domains, one of the things that keeps coming to the fore is what the role of the human is in all of this. As the previous speaker mentioned, at the different levels of autonomy, the humans are involved in different ways, between the seafarers on board a ship that has some amount of automated control, all the way through to remote control by humans at another location, or beyond that, completely autonomous actions by the vehicle. And this sort of this structure is quite common across all areas of automation, but we tend to think of it in terms of the actors or the stakeholders who are working with the system and using the system on a day-to-day basis, on an everyday typical performance. But in fact, it feels like that there is a much larger suite of stakeholders and actors involved in any complex system. It isn't just the people who are running the system on a day-to-day basis. There are, before the system is deployed, there are engineers and designers and manufacturing, programming people, all of whom have been have had an influence, have touched the system as it is being built and deployed. In our case, we're talking about ships and underwater vehicles. There's also a lot of people who are involved in the post-deployment maintenance. People doing repairs, people who are involved in maintaining service equipment, people who are involved in fueling and loading, unloading. All of these people have a role. They are actors in the behavior of any autonomous systems. Yet a lot of times we don't take their roles into account we put together these systems, we sort of assume that this work, the work of a design engineer designing some sets of sensors, that is somewhat separate or is divorced from the role in the everyday behavior of the system. We also don't take into account often enough the processes needed for training for malfunctions. In the aerospace arena, in the space arena in particular, NASA goes through a very, very extensive set of simulation trainings for malfunctions. All possible malfunctions that can be developed. The full crew, the ground crew, the space crew, and all support people participate in those simulations and work through the kinks of what happens when things go wrong. We don't tend to do the same sort of thing in our more everyday versions of dealing with automation, and it's not clear the extent to which that sort of dealing with things when things go wrong, how much of that is really to the forefront of the overall ecosystem that designs these devices. In the legal world, it's interesting because it does come to the fore among the legal profession because of the issues of liability and what is going to happen, how are disputes going to be resolved when things go wrong. But in the engineering world, I find it very surprising that there often isn't enough attention paid to this. One of the rules that I have all along is anytime any of my colleagues or people who report to me, anytime they come up with charts with circles and arrows and architecture diagrams and flow charts and so on, I insist that there's a human in there somewhere. That a system doesn't exist in a vacuum. There is always a human somewhere, some sort of human interaction. I quite often hear it from software engineers, and they say, "Well, it's just a routine. I have some inputs, and I process those inputs, and they go out. There isn't any human interface here." Yes, there is. The human interface is, in that case, is the other software engineer who was going to use this code. So always there are these interactions between humans and the technologies, which we really don't take sufficient account of. And when things go wrong, we really discover where the misunderstandings are, and sometimes it takes a very long time. If I may, I'd just like to share a screen here, if I may. Can you let me share my screen, please? What I'd like to do is just draw attention to an example that is used in the let me see if I can locate this. Yeah, in the human factors and human interaction world, there's lots of examples come from the aerospace industry. This is a report from some years ago about a Qantas flight that went completely out of control on a flight between Singapore and Australia, and they the crew eventually managed to recover it, and the flight landed. I'll say safely. There was a lot of people who were injured, and there was a lot of internal damage to the plane. But what's unusual about it is that there is the plane wasn't lost. That everybody survived. So there's much more insight into how things went wrong and how humans interacted with it. Basically, I'm not going to go into the details of the whole story, but basically the details are that the automated systems that were on board went out of control. It was impossible for them the crew to work out what was going on. That there were in fact 10 different failures that occurred simultaneously, and it's very, very difficult for systems to work for system designers to work in these sort of complex systems, especially when these type of problems don't crop up very often. So the crew doesn't have sort of day-to-day experience of dealing with systems that have gone wrong. And I think that that's one of the key important items here is how does the control get handed off between the automated system and the humans, and at what point does the automated system say, I know more about this than you do, I am seizing control? We've had that sort of control for a long time in anti-lock brakes. The braking systems in cars, they take over because the car knows, if you will, more about how to deal with a skid than the driver. But once you get to things that are way, way, way more complicated, this handing off of control, seizing control, and eventually deciding who's in charge, from a technical point of view, is really, really difficult. And I really feel that we don't pay enough attention to that. We don't pay enough attention to it in our engineering education and in our professional training. I have a story from some years ago. I was at a conference, and it was a software engineering conference, and the moderator asked, well, we're one of the who interacts with other professions here in the room? And almost everybody puts their hand up. Okay, so who interacts with medical doctors? Some people say yes. Interacts with people working in finance or in payroll. They have interactions regarding the systems that they're designing. And then you said, who interacts with lawyers? And everybody says, no, we don't want to deal with lawyers. That's just a nuisance. So you say, but hang on, we're talking about collaboration and interaction between people of different professions. And if anything, the law profession and the software engineering profession have a lot of things in common. Both professions are seeking to describe how the world should work and what should happen under what circumstance, and how society should deal with particular circumstances. But the two professions are using extremely different languages, and it's very difficult for them to talk together. And in fact, it turns out that here in Silicon Valley, the engineers who have law degrees and lawyers who have engineering degrees are very, very well paid, because it's a huge area. I have, and let me just say, I think one other item to share, two other items to share here. Just real quick. This is a poster of a conference that I worked on with a lawyer, a legal friend of mine, Josh Fairfield, where we studied the ethical procedures, ethical processes for studying studying people playing video games and working in virtual worlds. And there is an extensive body of work for identifying how that sort of human research should be undertaken. But there's a real need to harmonize the regulations and the policies for that undertaking that sort of research. The reason I bring this one up is because the interaction that humans have with large, complex, autonomous systems are not entirely different than the types of interactions that people have interacting with, using virtual worlds or interacting with video games. You are looking to assess the situation, understand what is going on in the environment, and take appropriate decisions. I don't think we carry on enough research in this sort of area for the management and control of unmanned vehicles. There's a very, very large amount of research still needs to be carried out there. I've got one other item. The issue of raising questions is what comes up here. I have some questions just to throw out for conversation, and maybe sometime during the rest of the session we might take a look at them. So, who are the actors? Who are the stakeholders? Who are all the human stakeholders that are involved in the system? What I said earlier, how do you transfer control between the humans and machines? How can research in other areas, like video games, or for that matter, ground vehicles and aircraft, how can those research influence our thinking? The whole issue of malfunction training, should there be more? Should it be mandatory? Is there some continuing ed type studies that is needed? And how do we apply this entire topic right across the engineering profession? The medical profession has mandatory ethics training. I think the legal profession is similar, but we don't have the same in engineering, and I think that's really, really unfortunate. Those are the questions I have, and I think I'll, as they say in the US Congress, I'll cede the balance of my time back to the chair. Thank you.
Thank you, John. Thank you. It's a very, very stimulating presentation, very stimulating focus on the human element. Yeah, I believe we all agree that the human element is always to be considered as in the center of any discussion. Maybe we are considering the autonomous systems sometimes more relying on AI, on artificial intelligence. So at that level, we maybe need to better enter the discussion on how AI can substitute the human element. However, I believe that the human element is still in the center of the focus, even at whatever level of automation we have in the existing systems, with existing industrial and transportation automation systems. So the importance of how the personnel is trained, and how the professional knowledge needs to be increased together with the development of the industrial and industrial solutions. I believe that is maybe the focus of the discussion. However, thank you very much, John. I believe that in the last step of this event, we can open the discussion to all the speakers. And I would leave the stage to our third speaker, Professor Massimiliano Musi, professor in Maritime and Transport Law at the University of Teramo in Italy. He's a senior research fellow with tenure in navigation law at the Faculty of Law of the University of Teramo. Professor Musi held lessons at the European Parliament for the Directorate for Legislative Acts. He is member of the Italian Association of Maritime Law and member of the Italian Association of Navigation and Transports Law. Professor Musi published 4 monographs, more than 60 articles, and case comments, and edited 7 collective volumes related to the matters of maritime and transport law. So Massimiliano, the stage is for you. Thank you very much.
Thank you very much, Mr. Chairman, for the kind presentation, and thank you again to the organizing committee, and especially my thanks are addressed to Mr. Alberto Casino, who is the one that directly invited me to this seminar. As you probably realized, after my brief presentation, I will focus mainly on legal issues. And as you probably have already realized in light of the 2 former presentations, especially the one of Mr. Longo Befano, in recent decades, maritime law is facing challenges that have never arisen before in its millennium history, during which many of the institutes and figures that characterize it, born in the distant past, such as, to name a few, general averages, salvage, limitation liability of ship owner, charter parties, bill of lading, the captain, the crew, have remained almost unchanged until today, making it one of the few bastions of stability in the face of a world pervaded by incessant changes. Now, more than ever, the so-called Lex Maritima, in order to maintain its uniform regulation function, at least in its pivotal institutes, on which it is substantially based, is called upon to resort to a wise balance between flexibility and rigidity. The evolution we are witnessing is profoundly modifying the perception acquired up to now of the ship, understood both as a res and as a traveling community, missing a characteristic which, despite the marked changes undergone in the last 2 centuries, has always been pervaded, namely the presence of the human element. Therefore, many questions have arisen about the need or not to reconsider the concept of ship in order to make these new fattispecious subject to domestic and uniform rules of maritime law in order to avoid facing the consequences of a substantial, very dangerous regulatory vacuum. The absolute relevance of the problem and its transactional connotation have prompted European institutions and international organizations to activate ad hoc projects and research groups. In particular, the European Commission promoted and co-financed the Maritime Unmanned Navigation through Intelligence project, the so-called Moonin project, aimed at developing and verifying a concept for an autonomous ship, which is defined as a vessel primarily guided by automated onboard decision-making system, but controlled by a remote operator in a shoreside control station. If we look at the acronym, it's pretty interesting because it does not seem to be accidental. Mooning, which in Old Norse means memory or mind, is one of the two ravens. The other one is Hugin, who in mythology sit on Odin's shoulders. The god sends them every morning to fly autonomously around the world so that once they return, they can whisper in his ear everything they have seen. In any case, after this historical digression, we have to say that at present, the project has highlighted that from a legal point of view, the autonomous ships do not pose insurmountable obstacles, and that the main questions to be resolved concerns the methods of allocating the duties of the captain. At the international level, the IMO has included in its 2018-2023 6 years strategic plan as a second strategic action that of integrating new and advancing technologies in the regulatory framework, with the primary aim of investigating the effects that the new technology may have on safety and security, on the environment, on the facilitation of trade, and among others, on the cost of shipping and on the personnel on board and ashore. Furthermore, in 2017, a study still in progress was put on the agenda aimed at verifying whether, in what way and within what limits, the activities of a so-called MASS, so a maritime autonomous surface ship, defined as a ship which, to a varying degree, can operate independently or partially independently of human interaction, can be regulated or not by the so-called IMO instruments of International Maritime Organization instruments. Already from this initial phase of analysis of the phenomenon, it emerges that certain advantages deriving from the mitigation of certain risks and the reduction of management costs are only partial, or in the state of the current technology, at least overestimated in my point of view. While it is true that the human factor, which statistically causes about 80% of accidents at sea, would be drastically reduced, in any case, it will still play a not secondary role in the direction of remote operation or in the programming of guidance systems. Furthermore, as the degree of autonomy increases, the usefulness of the bridge of the ship, the true real center of the ship, would proportionally decrease its essential function. This essential function is highlighted and reflected also in the International SOLAS Convention, where in its Regulation 15, in the Chapter 5, if I remember well, related to safety of navigation, specifies that the bridge design must be designed to facilitate the tasks to be performed by the bridge team and by the pilot in making full appraisal of the situation and navigating this ship safely under all operation conditions. Often, if we consider the practical issues to be faced by the crew, often we realize that the measures to be taken for the purposes of navigation safety must be evaluated in the light of the single contingent situation of which the bridge team can be fully aware only by being present on the bridge, from which it is possible clearly to have a privileged view of everything happening on and around the ship. Furthermore, the extremely short times in which certain decisions must be taken require a promptness of reaction dictated not so much by the rapidity of calculation in the solution of an algorithm, but by the intuition, this is my point of view, but by the intuition and experience of the captains. Qualities that are almost certainly lacking in a remote controller or worse, in a fully automated program. Moreover, the use of unmanned ships raises new problems both in social and occupational terms, and this is the ethical part. as well for all those who will no longer be able to provide a service on board, and concerning the identification of the applicable legislation, the security and the identification of the subject on whom the operation managerial responsibility will be channeled. For all those issues shall be adopted criteria that are calibrated on the different type of figure involved, be it, for example, a remote controller or a software designer, for example. Being heavily dependent on the use of digital technology, unmanned units are exposed to risks deriving from both hacking attacks, from their malfunction, and from, as Mr. Longo-Bifano correctly pointed out before, interruption in the connection with the ground control station, circumstances that once again open up further fronts. Among others, in a point of view, the question as to whether or not it is appropriate to resort to the regulation on producers' liability for product defects, whether in case it should be substantially objective also in a maritime context, or vice versa, whether the fault-based liability system can find space, are, in my point of view, still without a certain answer. Finally, last but not least, we should say, an essential question should not be forgotten. Even before attempting to solve the critical issues and questions posed by the use of unmanned vessels, especially in terms of regulation, a preliminary issue must be solved, which is whether they can effectively be deemed to be ships or not, on the basis of the rules of uniform international law and those in force at national level. At the level of uniform international discipline, a very varied landscape immediately emerges as the definition of ship differ, sometimes considerably, from one text to another, given that their extent is strictly linked to the scope of the application of the system of reference. And in other cases, they are even absent. If we look at the UNCLOS Convention, you realize that there isn't a clear definition of ship or vessel. Nevertheless, these definitions have a fairly standardized structures when they are present in the conventions and tend to be pretty wide-ranging. If we look at the definition given among others by MARPOL, CORREX, London dumping, SUA, wreck removal, conventions from the side of public maritime conventions, and AGRUDS, CLC, Montreal, HNS, and Salvage Convention from the side of private maritime law, we realize that they begin with a more generic wording, with which they include almost every kind of watercraft in the genus of ship, and then continue with a not exhaustive list of peculiar units to be assimilated to the ship. The multiple conventions, whether of public or private nature, are, however, united by the fact that the presence of a crew on board, in the end, is never a necessary condition for the attribution of the qualification of ship. Therefore, in order for a manned vessel to fall within the notion of ship and consequently to be subject to international conventions, it should be sufficient that they are equipped with the minimum essential characteristics without which it is not even possible to imagine a ship. These characteristics are substantially identifiable in floatability and the ability to move through controlled movements on or through water surface. Therefore, in the interpretation of the definition of ships contained in the norms, it would be for sure preferable to adopt a flexible and evolutionary approach. In order to find some conclusion, we can observe that if on the one hand, at the regulatory level, it is legitimate or perhaps even desirable that the various types of units are subject to partially different regulation depending on the human presence on board or not. On the other, the reduction of the involvement of human being would not be sufficient to exclude the unmanned ones from the category of ship. Otherwise arguing, one would arrive at a big paradox of considering any ship as such only when the crew is on board, and to strip it of its qualification whenever the crew is disembarked. So realistically, this first three presentation will raise a number of questions, as probably also the last one. So I will try to leave some time for the end. And thank you very much for your attention.
Thank you, Massimiliano. Thank you for your interesting presentation. Now I would quickly pass to Mr. Marco Imperiale, who is a lawyer and innovation officer at LCA law firm in Milan. His innovation officer role, Mr. Imperiale explores new and global trends in law with a view to leverage on new technologies to deliver better legal services to clients. He also serves as attorney and advises national, international clients, primarily regarding copyright and media law. He has a wide experience working with startups, both as mentor, lawyer, and negotiation advocate. Mr. Imperiale collaborates with Harvard Law School as teaching fellow for the Copyright X course. He has also given seminars and spoke at a number of panel discussions on copyright, entertainment law, and negotiation mediation. So, thank you, Marco. The stage is for you.
Thanks to you, Paolo. Thanks, everyone. Alberto for organizing that, Colette for the ubiquitous support, and all the speakers for the great speeches and all the insights provided. Last but not least, thanks to all the audience who stayed with us for so long. I will be fast, I will be quick, and I will try to introduce the difficult relationship between AI and law from kind of a fresh and dynamic perspective. So here we are. John, in his presentation, was mentioning that both engineers and lawyers try to see, what the world should be, and they're doing that in a pretty difficult way and pretty different way. And I couldn't agree more. Being a bridge and being a glue between these two different areas is very tough, but it's necessary. And I'm thinking especially to all the UIA members who are following us from civil law areas, because in the United States, maybe, you have a background in computer science, mathematics, statistics, and then you have a law school degree, same sometimes in the UK, but, in Italy, in France, in Norway, is not like this. So it's even harder for us to think in AI terms. So I would just focus on technical, juridical, and political issues, and then I will leave the audience, the space for all and the questions. Just a little preamble, it's pretty difficult to set boundaries between technical, juridical, and political issues. AI rules are very unique. I'm speaking about AI rules as AI regulations, but we are still in most of the fields in a pretty embryonic phase. Anyway, these possible regulations are very unique, that we need to adopt a different mindset. And the different mindset, whether we are speaking about autonomous vessels, self-driving cars, legal field, could be somehow, some way related to the other ones. Now, I'm just trying to change the slide. Okay, some technical issues. How much do we know AI? Because the AI is a pretty broad concept. You know, we have artificial intelligence, machine learning, who can be supervised and supervised, neural language processing, deep learning, you know, just, you know, AI includes machine learning and deep learning. Machine learning includes deep learning, and deep learning is different from AI and machine learning. And all of them have different ways of human intervention. Do we need a unique set of rules, or do we need different sets of rules? Is it possible to see a one-size-fits-all? Is it possible to extend software legislation thinking that AI is just a tweaked algorithm, or do we need something more, like I believe? Just to mention a very big problem, the black box one. I'm sure that John knows it pretty well. We don't know how the system reach a certain kind of solution with AI. We know the result, but it's pretty difficult to do reverse engineering, and this has huge impact in terms, as we will see, of liability and authorship, legal personality. And another question could be how much do we know the human brain? Because, for example, neural language processing is pretty much related to the way neural networks works, but our knowledge of the brain is growing exponentially. And is it a matter of technology or connection? Because I believe that with 5G is entering in the field, we will see a boost both in terms of AI effects and AI technology, and consequently AI rules. Colette, I have difficulties changing the slide. I don't know why, but could you please, you know, just go to the next one. Now, some juridical issues. Privacy, for example. Do we need consensus to train machines? And if yes, which kind of consensus and which kind of uses for the collected data? Bias, because we know that AI systems respond to what we put in the system. So if we put good stuff, AI will deliver good solutions. But if we put bad stuff, AI will deliver bad solutions. So a lot of what we provide to a lot of the AI results are related to what and how we train the AI system. Ethics, you know it better than me, how much our world will change. Territory, from a maritime perspective, Massimiliano will give us a great answer about this. But if we have a broader picture, you know, having a local, global, or local approach can have different outcomes. Legal personality, cybersecurity, liability, ownership. And of course, there are political issues. So is it already too late to speak about regulations and legislation for AI? Maybe I'm a little bit pessimistic, but I think yes. In Italy, we say I buoi sono già scappati. And I'm afraid that we will see with AI what happened, for example, in copyright regulation with the advent of Napster, or in banking regulation with the advent of ICOs, that the technology goes on and it goes faster, and the companies and the people adopt that system, and somehow, some way, who does the rules has to follow what have already happened. So the legislator don't have the possibility to legislate on something and to shape the society according to the chosen principles. And of course, in AI legislation and regulation, there's a big role for the corporation, because you know, even with unmanned vessels, speaking about, you know, Google, Facebook, Microsoft, Amazon is not out of the field. And this for a couple of reasons. Mainly the first one is that all AI rules will see the influence of the dialogue of the corporations, especially big ones, with the various governments. And secondly, because most of AI systems are not built on premise, but they can use pieces of Microsoft software, pieces of Amazon cloud, pieces of, you know, Oracle systems. So somehow, some way, the rules for the corporations are intertwined with AI as we know it and AI that relates to our field. Can we cope with a society where corporations can issue their own rules and sanctions? Can we adopt a statistic mindset? So I'm seeing a world 5 or 10 years from now where self-driving trucks, cars, can be more reliable than drivers. And I'm not an expert in terms of technology, in terms of vessels, but I wouldn't see too far. But truth is, can we conceive the possibility of a mistake from the machine, even though statistically is the best possible choice? And last but not least, how far can we stretch the current norms? Of course, each one of these points would require hours and books to be analyzed properly, but I would just would like to go fast and launch the debate. My 2 cents is that as legal professional, it is necessary to redefine our approach to the law. So currently, the law follows the technological evolution. The law follows the society, but it's a slow, very bureaucratic, complex process, and I believe is not suitable for exponential innovation. What I suggest, and we have already seen an example with the FinTech regulatory sandbox, is a design thinking approach where different regulatory solutions contemplate a prototyping and with several players, testing, feedback. It's a faster, it's an interdisciplinary, it's an hands-on approach. And it will allow us to consider, you know, like in privacy by design, where we are thinking about privacy rules with already the legislation in mind, to conceive AI rules with already the rules, with AI technology with already the rules in mind. What does it mean? It means that it's time maybe for a paradigm shift. Some legal experts are also believing that AI law is not law at all. We should just think about a different term, a different concept. Maybe that is too far, but certainly it's necessary to make some reflections as soon as possible about this evolution. To conclude, I believe it's necessary to shift mindset and to intervene urgently on the regulatory aspect. The risk is living in a society where companies are forced to establish and follow their own rules. Rules are not suitable or not coherent with the technological scenario. And the worst case scenario, rules are not followed. To wrap up, a final quote from Stephen Hawking, who said that success in creating AI would be the biggest event in human history. Unfortunately, it might also be the last, unless we learn how to avoid the risks. And I believe, maybe because I'm a lawyer, that us as lawyers can do a lot for this goal. Thank you very much. Now, I'm getting back to Paolo for the final remarks.
Thank you, Marco. Thank you for the very interesting and stimulating presentation. Yes, the last sentence make us very sometimes doubtful on the progress, but I believe that the application of AI and anything else could still be considered as a big support to the human element that we need to have always in the loop. Thank you, everybody, for the very interesting introduction and presentation. I would pass to the Q&A section. I've seen we received some questions from the audience, and I would read them and try to see if I can drive them to the right person, or you all can provide your better answer or your better comment. First one is coming from Mr. Duncan Duffy from Lloyd's Register. The legal framework for operating ships assumes suitably qualified and experienced crew to carry out decision-making, with qualification regulated by national authorities. When that decision-making passes to a computer-based system designed by a software system provider, does the ship owner remain liable, and has the national authority responsibility passed to another party? I would ask maybe this to Massimiliano, maybe is the better placed for this, or whomever.
For sure, with pleasure. Thank you for the question, Mr. Duffy. I have to distinguish the two different typologies, in the sense that, as mentioned before, we have to consider that there are up to date, some vessels that are remotely controlled. But honestly, today we don't have the fully autonomous one. And as Mr. Longovifano said in the first presentation, the fully autonomous ones probably will be ready in 10, 15 years, not now. So clearly, even the legal framework related to the fully autonomous ones is not already set, unfortunately. However, the Comité Maritime International, probably as you know, so the CMI, have dedicated a subcommittee who is focused on the unmanned vessels, and according to the results of the questionnaires that have been sent to all the delegates of a number of nations, it seems that if a ship is remotely controlled, and this is clearly a reasonable answer, both the responsibility and the liability of the operations, and in case also of accidents and damages, will be on the shoulders of the captain, that could be at the shore base, and on the crew, and on the other side, for what concerns especially the liability, on the ship owner. So in the end, we will see what will happen in future with the fully autonomous one, but probably now the main debate is related to the one that are remotely controlled by a shore base.
Okay, thank you, Massimiliano. Is anybody willing to add something to this interesting question? Otherwise, I would pass to the next one, coming from Mrs. Barbara Gislason. I hope to read correctly the name. With regard to a uniform approach, what restrictions should apply to autonomous manned military-style vehicles used to control peaceful protests or civil unrest? I believe this is not strictly related to the maritime industry, but more generic. Maybe Marco, do you have maybe some ideas on this aspect?
Yeah. It's pretty difficult to have answers. So we could have proposals, but I think that I think it's up to the single states and to the to the producer of the vehicles to find a solution. I mean, I tend to be biased because, you know, I'm a peaceful kind of guy, so it's pretty difficult to relate with this kind of concepts. But once again, from what we are seeing in you know, war zones, it's pretty much urgent, not only to define regulations, because most of the times there are regulations, but to evaluate how we enforce them, especially in the international scenario. You know, AI will affect our world at 360 degrees, from how we cook to how we work, to, you know, how we drive, and last but not least, to how we protest. And I believe that we could still have a coherent 360 degrees kind of approach towards these systems. But in most of the states, this kind of approach is lacking. And even more, you know, most of the states have different ideas about how to, you know, intervene on this kind of issues. But I'm going maybe a little bit too far now.
Yeah, I can give an answer from technical point of view. Clearly, from the restriction should be that we provide a solution, an unmanned vessel that is no armed for sure, and is as redundant system, so, and very semi-autonomous with redundant communication. So we can take control in every moment. This is what we are doing to have a safe vessel. On the other side, we are studying to create the mission boundaries in order that that kind of vessel can do only that kind of mission and have specific rules to follow.
Thank you, Claudio, and thank you, Marco, for your answers. Next question, still from Mr. Duncan Duffy. I would ask probably to John on producer's liability. How would this work if the ship is not placed in the market as a standardized product by a technology provider, but rather is delivered as a tailored bespoke product in accordance with a specification developed by a prospective owner? So a tailored product under a specific requirements. Maybe John.
Yeah,
can you give your?
This one is it's an interesting concept. When I saw Mr. Duffy's question earlier, it came to my mind that a lot of the legislative side of product does seem to be related to standard products where people the same product is being sold to a large number of different users. In the case of these large systems, and we have to think of them as being tailored, bespoke products that are set up for a specific individual. It would be like saying, we're talking about systems that are really complicated here. It would be like saying that an airport is generic and that people sell cookie cutter airports in different places. These sorts of things are always tailored for specific purposes. I feel. I'm thinking of large vessels, and I suppose there's a different sort of different approach might be appropriate for small recreational vessels. Is for automobiles, but having a structure that is centered on services being provided, specific tailored services and tailored equipment is. I think it has to be that way for these sorts of systems.
If I may add a couple of considerations from the legal side, I think that these questions has to lead us to think at least two issues. The first one is that probably the solution will be solved from one side on a very general basis by an international discipline, but specifically on a contractual level. So as most of us know, the maritime law and maritime commerce market is generally regulated by formats that are provided by associations or entities, bodies that are internationally renowned. So realistically, the, let's say, general conditions of the producer liability could be set in a format or in a number of formats, such as now happens for the charter parties and other kind of contracts. And the second issue is that we have also to focus on the fact that it's not only the problem of the producer liability, but also of the figure of the ship owner. A ship owner could be considered as a consumer or not, probably not. So clearly the actual EU system concerning the producer liability or the actual national domestic laws concerning producer liabilities are not clearly fully fit in order to regulate this kind of stuff. But as said, we have some years to study it and to draft some clauses, formal clauses, or draft parts of legislation to be implemented both with international organizations and both with governments.
Thank you, Massimiliano. Maybe Claudio, do you wanted to ask anything maybe on this? You have the microphone muted.
Okay, yes. From our point of view, so who produced this, usually like technologically provider, we have a case-by-case solution. So at the moment, we don't have a standardization on this. And the customer asks us to add this or to leave this. So we are trying to do an effort to follow some rules and align with this. But like someone said before, we are releasing technology, but we don't have the rules. So probably the law will follow us later.
Thank you, Claudio. I have only just last question from, I believe, from a lawyer, is Mrs. Cristina Lucrecia Juan Vidal. What about innovation in law? Meaning the ways of giving us, so this is probably, most probably a lawyer, giving us the rules and the solutions of the AI conflicts. So I would leave this open to Massimiliano and Marco.
Sure, it's not $1 million question, it's $1 billion question in my point of view. In the sense that it's pretty clear that according to the progress in science and technology, now we have to rethink many sectors of the society, and especially they rethink how to shape laws and so on. But this is, in my point of view, way beyond our ability now. So realistically, as Mr. Lugubifano said before, and as is happening in the last decades, unfortunately, law has to follow the novelties instead of being drafted before in order to regulate them. So this is a big issue. It says that in the first years, in the first cases that happens during the first years, probably there will be a substantial legal background vacuum, and only after some time the legislator will be able to be ready to issue a possible regulation that will be in any case always ongoing and always under modification. But now, honestly, it probably is too early to forecast how this kind of sector, you know, for what concerns especially the regulation provided by international convention, international institutions, or even countries, what kind of direction it will take.
Well, I'm getting in the loop, and you know, my half is on the one hand half full, and on the other hand half empty. It's half full if we think at the etymology of the term innovation. It, you know, it comes from the Latin, you know, innovare, which means looking at things from a new perspective. And I believe that this is the right time and this is the right opportunity to think about new ways. And the half empty glass is because this specific concept is pretty tricky, because on the one hand, you know, everybody, not only lawyers, I mean, everybody has an opinion, especially on pretty basic issues, but at the same time, the level of complexity, as you know, we have seen with some of the technology or some of the legal implications, is very, very high. And so we have to manage these two aspects. At the same time, the time frame is different because the legal time frame is pretty slow, and the technological time frame is pretty fast, and it goes in an exponential way, not in a linear, not in a logarithmic one. It goes in an exponential one, which means that unless we redefine how we conceive the law, how we conceive the rules will not be adapted to the system. It's a billion-dollar question, like Massimiliano was saying. It's a pretty great challenge. And last but not least, I think that you know, we need to solve this challenge together. So having a kind of a pretty unique mindset, because once you mix different territories with different legislation and different technologies and different connectivity, the scenario complicates even more. So to make it a little bit easier, we need to have a global strategy, but it's harder than it seems.
Thank you, Marco. Thank you, Massimiliano. I believe we finished our time. We a little bit exceeded our time frame. So I would like to thank you very much to our excellent speakers, and thank you to the audience for their active participation and for stimulating questions that you asked to these excellent speakers. Thank you, Colette, for your technical assistance. And I will leave the last word to Alberto for his greetings, and thank you very much for having invited us to this interesting and stimulating event.
Well, Paolo, thank you very much for giving me the floor for this last few words. I'm very happy in the sense that when we organized this panel, we were puzzled. We were thinking, what would be the replies given from the lawyers to the scientists? And I see too, there is a double approach we can have to this issue. From one point of view, it's very clear that law is listening, at least in maritime law, and with connection to the unmanned vessels, is listening carefully to what's going on a technical basis. And so this is, it's an interesting point. The second point, though, might be summarized as follows. There are, for example, the code regs, so the rules to prevent collision at sea, which are considered a set of best practice. And the point is that if we want to change them so that they can cope with navigation of unmanned vessel, we shall have a practice. And this is the point that somehow has been raised by Marco. Law is frequently following, and this might be a great problem. But from maritime law, this might be considered slightly differently, in the sense that maritime law tends to regulate things considering the various technical patterns and considering the practical situations, and then regulating them. So I have two feelings. From one point of view, we shall be very happy on how lawyers speak with scientists. They do speak, and to a certain extent, they at least try to understand each other. And on another hand, and at least with concern to maritime law, let's be optimistic in the sense that we are proceeding very slowly. We're trying to understand how to change rules in connection with the new inventions that are going on in the sector of unmanned vessels. And so we at the very end, I think we shall be very happy with the outcome of this meeting. And I thank you all for being attending today. A warm thank to the chair, to the speakers, and see you all tomorrow to the next panels on telemedicine and on genetics. Goodbye.
Thank you, Alberto.
Thank you very much to all of you and to the attendants. Bye-bye.
Thank you very much. Bye-bye.
Bye.
Thank you very much, all.
Thank you. Bye.